We'll be doing this question today. Okay. Yes, before that, everyone, please turn on your camera. Yes, Aisha. Yes, let's continue. So, here also we have to prove that, we have to show that left hand side and right hand side are same. Okay, let's see how can we do so. So, if we'll be taking left hand side, this one, 1 plus sin A over 1 minus sin A. Now we need to think what can be done over here. Okay, what can be done so that we'll be able to able to generate sec and tan. So whenever this type of fraction will be there, no, always try doing the try applying the logic which you used to apply in while doing the rationalization. Okay, rationalization you must have learned in previous class, where if 2 plus root 3, this type of uh, rational expression will be there, then what we used to do, we used to multiply with 2 minus root 3 in the numerator and denominator, and then we used to rationalize it. Same concept, whenever you are having numerator and denominator over here, if nothing is working, try applying this logic. Most of the time it will work. Okay, here also if you will find, if you will do the same thing, in denominator 1 minus sin a is there. Okay, we need to multiply, we will be multiplying in this root only, inside the root. Okay, we will be doing the multiplication of 1 plus sin a over 1 plus sin a. Okay, why we are doing so? Because we have seen the denominator looks like a minus b, so a plus b, we are doing the multiplication in numerator and denominator, and keeping in mind inside the root we are doing the multiplication. Now the question is that allowed? Yes, we are just having a fraction inside the root or outside the root, we are just having a fraction. Okay, and in that fraction we are multiplying same thing in numerator and denominator, that is completely fine. Okay, so we did this much. Now in numerator it is 1 plus sin a, 1 plus sin a, so we can write it as a 1 plus sin a whole square. And in denominator it is a minus b, a plus b, so it is just a square minus b square. Now we have learned three identities. The first one we can apply in the denominator. Denominator is just 1 minus sin square a. What can we written for that? At the place of 1 minus sin square a, what can be written over here in the denominator's part? Anyone?
Cos square A.
Cos square a. Okay, we will be able to replace it with cos square a by using the first identity, and the numerator's term will remain as it is. Now you will find that we can take it out, the numerator and the denominator, from the root sign, because it's having it's perfect square, whole square. Okay, so 1 plus sin a will come out from the numerator's part, just cos a will come out from the denominator's part. Okay, now if we will separate it, if we will write it as a 1 by cos a plus sin a by cos a, we are done with the proof. Check it. We are done with the proof. This is nothing but sec a, and the other one is nothing but tan a. So we were having 1 plus sin a, 1 minus sin a, and we wanted to prove sec a plus tan. I told you, like sometime we need to do apply the logic which we used to apply while doing the rationalization. So here the same logic we have applied. Inside the root we have done the multiplication of 1 plus sin a, 1 plus sin a, numerator and denominator. Okay, now whatever just came in our way, we just kept on doing 1 plus sin a whole square and denominator became a square minus b square. Denominator became 1 minus sine square a. Denominator became cos square a. And this is what we ended up getting, and we are done with the proof. This is only RHS. Is it clear to all of you? Yes, is it clear?
Yes, ma'am.
Yes, ma'am.
Let's continue. Sine theta minus 2 sine cube theta over 2 cos cube theta minus cos theta is equals to tan theta. Let's prove it. Left hand side and right hand side both are same. So just like any other question, we'll be taking left hand side. Just a second. Yeah, left hand side, which is sine theta minus 2 sine cube theta over 2 cos cube theta minus cos theta. Can you see something we can take out as a common factor from numerators part? And also something can be taken out from the denominator also as a common factor. What can be taken out from the numerator? Who will say? Yes, sine theta and 2 sine cube theta. These two terms we are having. And if I am asking you, what can be taken out as a common factor?
Sin theta.
Yes, sine theta we can take out common factor from the numerators part. Remaining will be 1 minus 2 sine square theta. And from the denominator we can take out cos theta common. Yes, and what will be remaining? What will be remaining in the bracket?
1 minus 2 cos square theta.
No, ध्यान से देखो.
Cos square theta minus 1.
2 cos square theta, right? Minus 1. Yes or no?
Yes.
Yes.
Okay. Now what we want to prove, tan theta. So now only it's making tan, the outside whatever we have taken out as a common factor, this sine by cos is making tan. That means this bracket is these are the extra terms we are having. Okay. Okay. If these are the extra term, then we will focus on cancelling them. Maybe we will be able to cancel them. So 1 minus 2 sine square theta we are writing as it is, and the denominator, this cos square, let's change it to sine square by using the first identity, that is sine square theta plus cos square theta is equals to 1. Okay, we can take cos square theta is nothing but 1 minus sine square theta. Let's replace the denominator cos 1 with the sine 1. Okay, maybe we will be able to cancel out the bracket term by changing it in sine form. So it is 2, and cos square, at the place of cos square we are going to write 1 minus sine square. So 1 minus sine square theta minus 1. Okay, let's simplify. So 1 minus 2 sine square theta we are having in the numerators part. Of course, this common factor is still there, sine theta by cos theta. And here we are having, let's open the bracket, it will be 2 minus 2 sine square theta minus 1. When we will do the simplification, what are we going to get? Can you please tell me the denominator bracket part? When we will do the simplification, what will be there? Yes, anyone? Will it be 2 minus 1 is just 1? Minus 2 sine square theta? Yes or no? Yes or no? Are you getting it?
Yeah.
Okay, this was just 1. So 2 minus 1 is 1. Minus 2 sine square. This one gone. And we are done with the proof. Check it. Tan theta we ended up getting What we did, just we have taken out the common factor and we have applied the identity. Why we have applied the identity in the denominator only? Why not in the numerator? It's completely up to us. We can convert the numerator one like the denominator, or we can convert the denominator one like the numerator. Okay, we just need to make it same, either sin or cos. Okay, you will find that both are cancelling each other and tan theta only you are left with. Is it clear?
Yes.
Let's go. Let's do. Yes, everyone, have you copied it? Both the question which we have discussed so far. Yes or no? Let's do the next one.
Yes, ma'am.
Sin A plus cosec A whole square plus cos A plus sec A whole square is equals to 7 plus tan square A plus cot square. Okay, we need to prove that left hand side and right hand side both are same. Let's do it. If we'll be taking left hand side over here, that is sin A plus cosec A. We are having at first, just by looking at the left hand side, two things are coming. Two things must come in your mind. That is, we can just expand it by using a plus b whole square formula. Maybe that we can do, or at first we can convert this cosec as a 1 by sine, this sec is a 1 by cos. Like from this to anything can be done over here. Right? Right?
Yeah.
Can you see we can use the formula a plus b whole square here also, here also. Let's see whether it will help or not. Okay, let's see. So if we will use the formula a plus b whole square for both of them, it is just a square, okay, plus 2ab, 2 into a into b, plus b square. Okay, similarly a square plus 2ab plus b square. Now, after this step, we can see here sin square A is there and here cos square A is there. So whenever we'll be having this type of situation, quick, we will just take both of them together and we will make it one. Okay, so here also sin square A plus cos square A is nothing but just one. Write it together if you want. Write it. Sin square A plus cos square A is just one. Now the remaining terms we will copy down as it is. So this cosec, still we want to convert this cosec as a sine. So can we say it is just 2 sine A and cosec is 1 by sine. 1 by sine A. See sine A gone and we are left with just 2 over here. Just 2. Okay, from this term we are getting only 2. Similarly, like let's copy this cosec square as it is. This 2 cos cosec A sec A, this will be just 2. Can we write or just write it this way? 1 by cos A. Okay, this gone, just 2 we are having plus sec A square. See, we are not leaving any term. We have carefully we have copied down each and every term over here. If you want, please check it. Okay. Now, this sin square a plus cos square a, this is just 1. Here we ended up getting just 2. Here we are having cosec square a. Here we are having again just 2. And here we are having sec square a. Let's add all the numbers. Let's see what are we getting. 2 plus 2, 4 plus 1, 5. 5 we are getting. Okay, 5 plus cosec square a plus sec square a. Now let's see the proof, what exactly is reflecting in the proof part. So in proof, tan is there and cot is there. And what are we having? We are having sec and cosec. So we know there are identities which will help us converting this cosec in terms of cot and converting this sec in terms of tan. Okay. The second identity was sec square a minus tan square a is equals to 1. What was the third identity? Who will say? What was the third identity? Last identity. Yes.
Cot square a plus 1 is equal to cos x square a.
Cot square a plus 1 is equals to cosec square a. Yes. Yes. We also say it like cosec square a minus cot square a is 1. So yes, these identities we are having at the place of cosec, we'll be writing cot square a plus 1. Perfect. Harshit. Sec square a at the place of this one, we'll be writing 1 plus tan square a. Okay, both are just added together and 5 is there. So we can see again we can see that 5, 1, 1, 5 plus 1, 6, 6 plus 1, 7 we are getting. And we are done with the proof. Check it. Check it. We are done with the proof. This is what we wanted to prove. Let's check. Yeah. Cot square is tan square. 7 plus cot square plus tan square. This is only RHS we are having. Let's summarize what we did. So at first it looked like a plus b whole square. Okay, it may work, it may not work. Two things was coming in our mind. At first let's apply the rule over here, that is a plus b whole square formula. And the second thing which was coming initially in our mind was, let's convert this cosec in terms of sine. So anyone you can try. It may work, it may not work. If like any one from these two possibilities working, then you don't have to think about the other one. If it is not working in case, then you have to use the second approach. Okay. So we applied one approach over here. We used the formula of a plus b whole square, and it seemed like yeah, it's working. And just by expanding in, we were able to make 1 plus 2 plus 2, that is 5, we were able to make over here. Check it. And in our proof part, 7 is there. So if 5 anyhow we have made, 7 also we will be able to make. Okay, cosec and sec was there. We just used the identity over here, and then we are ended up doing the proof, ended up getting the right hand side. Is it clear to all of you? Is it clear?
Yes, ma'am.
If it is clear, let's
Yes,
proceed
ma'am.
with next one. It is cosec a minus sin a in other bracket sec minus cos a is equals to 1 by tan a plus cot a. Okay, this is what we have to prove over here. Again, we'll be taking left hand side, and we can see what can be done over here. Okay, what we have to prove, that is okay, but what can be done at first, what is coming in our mind, so that only we will be doing at first. Sec a minus cos a. Now if I will ask you that you tell me what can be done initially, what is coming in your mind, what are you thinking about this particular step? Anyone? What can be done at first? Can we convert this cosec as a sine and this sec as a cos? Can we? Yes, we can. Are you thinking the same? Yes or no? Yes,
Yes.
students. Yes. So you are also thinking the same. That yes, at first we don't know what to do, where to go, but this cosec we can for now we can convert this cosec as a sine. Okay, and as it is the other side, and the sec we can convert for now as a cos. And after doing this step, we can focus on doing the simplification. Maybe we will be on the right track. Okay, so let's try doing the simplification and let's see what are we getting. What will be the LCM in the first bracket?
Sine A.
Sine
What will be there in the numerators?
A minus
No. 1 minus sine square A.
Yes, it will be 1 minus sin square A. Everyone getting it? Here denominator is 1. LCM is just sine. Okay, the first numerator will not change. It will remain as it is. The second numerator, in the second numerator term, one more sine A will get multiplied. Everyone getting it? Yes or no?
Yes, ma'am.
Okay, here cos A is the LCM, and what will be there in the numerators part?
1 minus cos square A.
Yes, it will be 1 minus cos square. Now, does it looks like identity that we can use identity over here? 1 minus sine square A is nothing but it is 1 minus sine square A is what? The first identity is sine square A plus cos square A is equals to 1. So, at the place of 1 minus sine square A, what can be written?
Cos square A.
Cos square A over sine A. At the place of this 1 minus cos square A, we can write sine square A over cos A. Now let's see any cancellation is possible or what, because both are just in multiplication with each other. So yeah, this sine A and one of the sine from here we can cancel, and this cos A and one of the cos from here we can cancel, and we can see that we are getting cos A by cos A into sine, right?
Yes.
Let's see what is there in the proof part. It is 1 by tan A plus cot A. Okay, now there are two options. Either you sit and just keep on thinking that how to make it 1 by tan and cot, or you start working on the RHS part quickly, and the same result if you are able to generate from RHS, then we are done with the proof. So let's try doing that. So RHS, let's take, there must be a way from here to go to RHS, but that way we have to just like we have to think that how we can do the arrangement. Okay, otherwise you can take RHS 1 by tan A plus cot A, and quick you can work on that. Tan A plus cot A is like, it's like this only, right? Just a second. Yeah, it is like this. So now we can, what we can do, we can convert this tan in terms of sine and cos. We can convert this cot in terms of sine and cos. So we'll be having 1 by sine A by cos A, and cot A will be cos A by sine A. Now we can do the simplification in the denominators part. LCM will be, who will say what will be the LCM? What will be the LCM?
Cos A into sine A.
Yes, cos A into sine A, and what will be there in the numerators part over here?
Sine square A plus cos square A.
Yeah, sine square A plus cos square A. Okay, and we can write it as a 1 into, let's write the reciprocal, cos A sine A over sin square a plus cos square a, which is nothing but just 1. Okay, so this denominator we knew that it's 1. We are just left with cos a into sin a, and that's what we have generated from the left hand side also. So yeah, it was not that difficult. It's very simple. We can say that now LHS and RHS we have shown that both are equal, and we are done with the proof. Hence proved. Is it clear?
Yes.
Now we'll be doing the last question from everyone. First try it, okay? Then we'll be discussing, because it is nothing like, it's exactly same like the question which we have done so far, converting every time in terms of tan in terms of sine and cos, cot in terms of cos and sine, and then thinking about how can be done for doing the simplification. Please do it. No, we have to prove that, this this one, like the middle one and the last one, both are like all are equal with each other. So at first what you can do, you can work on this one. Okay, this complete expression you can take and solve it and tell me what are you getting. Just that. Please do it, no everyone.
The
What you got?
tan square A.
Tan square a. Everyone got the same? Have you got tan square a? Yes, is it tan square a?
Yes, ma'am.
Yes,
Yes,
it
ma'am.
will be tan square a. Okay, 1 plus tan square a. You are working on this expression, 1 plus tan square a by 1 plus cot square a. Here you must have converted this tan in terms of sine and cos. This sine square a by cos square a, and this cot in terms of again sine and cos, cos square a over sin square a. Now you must have simplified the numerator and denominators part. So it is just cos square a LCM, and here it will be cos square a plus sin square a. Okay. Now in the denominator it is sin square a, and here we are having sin square a plus cos square a, and from here only you will get just the sin square a cos square is 1, so just tan square a. Now please do the simplification for this middle part, this middle expression, 1 minus tan a by 1 minus cot a whole square. Now you have to work on this one, 1 minus tan a by 1 minus cot a whole square. Please work on it and let me know what are you getting.
tan square a.
Yes, from here also everyone getting tan square a. That means we are done with the proof. We are done with the proof if the first expression is generating tan square a, the second expression is generating tan square a, and the last one is just tan square a. So we can say the first one is equals to the second one is equals to tan square a. Of course we can say, right? We are done with the proof. Hence proved, you can write it. Any confusion? Anyone having any confusion? Okay, it's that simple. You just start solving question. Let me take few more extra questions. Just a second. Let me take it up. Okay, one of the question is like this. Please try doing it. If sine cube is equals to a square minus 1 over a square plus 1, then the value of sec cube plus tan cube will be functions of a by root 2 a by a square plus 1 Just okay. Aisha said that it is option B. I am waiting for other students.
Option B, ma'am.
Option D. Yes, Arshid, Aisha, Zana. What? Zana, you said option B. Fazan said option A.
Ma'am, it's
Right, Fazan?
option B.
D or A?
Ma'am, option B.
Okay, you are saying B.
Yes, ma'am.
Okay. Yes. How you did this? Anyone who have already done? Yes. How you did it? Aisha, Harshit, Zanab. How you did it? Fazan.
Ma'am,
Yes.
we first I use the identity of the sine square q plus cos square q is equal sine square theta plus cos square theta is equal to 1.
Yes.
So I put it and then to find uh, cos q.
Yeah. Sine square q plus cos square q is equals to 1. This identity you have used to take out what exactly is cos q. So sine that means
So
cos
I got
square q. Yes, please continue.
so then I got sine square q is equal to a square minus 1 by a square plus 1 whole square, which is also equal to a square minus 1 whole square by a square plus 1 whole square.
Okay, here we will take LCM. Like this we can write, and the LCM will be a square plus 1 whole square, right?
Yes.
and here we'll be having a square plus 1, that's whole square, minus a square minus 1 whole square. So a square minus b square type of structure we are having. A plus b in one bracket, a minus b in another bracket we can write, or you can use the identity a plus b whole square, but that will be bigger. This will
I
be
use a square
smaller.
minus b square.
Yeah, so a plus b in one bracket, and then a minus b in another bracket. Okay, be careful with the sign. See carefully, I have written here plus sign, this plus sign. Okay, because when you will do the subtraction and then you will write a square minus 1, and when you will open the bracket it will be minus a square plus 1. Okay, so we have to be careful with the signs. Now when we will do the simplification, denominator will be as it is, numerator will be numerator over here, denominator will be as it is, that is a square plus 1 whole square. Numerator will be a square, that is 2a square, and a square 1, that is just 2. And in denominator we'll be having a square plus 1 whole square. Okay, this is our cos square theta, cos square theta. Cos q will be, see carefully, we are having 2 into 2. If we will just write everything inside the root, what will come out? 2 will come out, a will come out, and a square will be there. A square plus 1 will be there, right? Right?
Yes.
Okay. So cos q we got, sin q we know. Now we have to find this sec q plus tan q. Now only we learned that whenever we are having sec tan, we can convert it in form of sin and cos. So let's convert it quickly. It will be 1 by cos q plus sin q by cos q. LCM will be just cos q, and numerator is 1 plus sin q. If you want, do the addition over here. If you want, do the addition in the rough space. It's completely up to you. 1 plus sin q we need to find. 1 plus a square minus 1 by a square plus 1. This is there in the numerator, and in the denominator just 2a by a square plus 1. So basically it's all about simplification. Okay, you have to take the LCM here, that is a square plus 1. Here we'll be having a square plus 1 plus a square minus 1 over 2a by a square plus 1. 1 gone. We are having 2a square by a square plus 1. Okay, into this denominator we can just write the reciprocal of this one. This is a square plus 1 by 2a just. Okay, 2 gone. A with a gone. Be careful, we are left with one a over this and this gone. So a we are getting only. Yes, option D is the correct option. Can you see it? Everyone getting it? How we are doing it? Yes or no? Yes, are you getting? This way only you have done, Aisha, Harshit, or any other
Yes,
way?
ma'am. No, ma'am, this way.
This way. Okay. Please do this one. The numerical value of 1 by cos theta minus 1 by cot theta, 1 by cos minus 1 by cot. Wait. Yeah. Is options are 0, 1, minus 1 and 2. Please do it. Same thing is there in both the bracket. Yeah. Please do it. Check it. What are you getting? Yes, Zana. Yeah, sure. Yes. Yes. Are you able to do it? Yes. What exactly are you getting from here? Please tell me. It is 1 by cos theta minus 1 by cot. Okay, cot can be written as cos by sine, right? And the same thing is there in the other bracket also. Same, exactly same. So what are you getting from here? It is 1 by cos, and this sine will go over here. So we'll be having something like this, sine theta by cos theta. Yes or no? And the same thing like 1 by cos minus sine by cos will be having in the other bracket. Now we can take out cos theta as a LCM, and we'll be having 1 minus sine theta, 1 minus sine theta over here. Just a second. Just a second. 1 minus sine theta over here. 1 minus sine theta over here. Cos theta and cos theta, we can write it together, cos square theta. Okay. Now if we will use the formula a square minus 2ab, okay, minus plus b square. Are we getting anything? Like the value we are supposed to find. Just a second. Let me check whether the question I have copied correctly or not. By cos theta minus 1 by cot theta. Okay. We can write it as a sec theta also. We can write it as a tan theta also. Okay. We can also write it as a sec theta minus tan theta. So basically it became sec theta minus tan theta whole square. And the formula identity is sec square theta minus tan square theta. That is one. Can be done. I need to check the question first. Okay, then we'll be